Hey, what's up, guys? Hope you're keeping well. It's December, last month of the year, and time has just flown by this year. I mean, honestly, it has really flown by. Yeah. So, anyway, today we're gonna be looking at linear algebra, and specifically looking at the Cayley-Hamilton theorem. Okay. So, what is the Cayley-Hamilton theorem? So let Px be the characteristic polynomial of a square or n by n matrix, and let's just call it matrix A. Yeah. Then PA is the square or n by n zero matrix. Okay, right. So what I'm going to start doing is I've got my matrix, matrix A. So A equals minus 3, 16, minus 1, 5. And I need to find the characteristic polynomial, which is determinant minus identity, then x, my variable x equals 0. So substituting values into that, so that'll be minus 3, 16, minus 1, 5, and then x 0, 0x, which then becomes so minus 3 minus x, 16 minus 1, and then 5 minus x. And then further simplifying. So what I'm going to do now is I'm going to multiply these diagonals, right? And then subtract this diagonal from this diagonal. Okay, so minus 3 minus x, and 5 minus x. Okay, which is equal to 0. So further simplifying, so then we get minus 15 plus 3x minus 5x plus x squared plus 16, which becomes, then furthermore that becomes x squared minus 2x plus 1. Okay, so that's our characteristic polynomial. Okay, right. So taking things a step further, we're gonna substitute where there's a's, we're gonna put where there's x's, we're gonna put a. So x squared minus 2x plus 1 equals 0 becomes so a squared minus 2a plus I, which is the identity matrix. Okay, and then a squared is equal to 2a minus I. So that's essentially just moving that to the right. Yeah, to the right. Okay, and then so since a squared equals 2a minus I, then finding a4, a to the power 4. So all we do is just square that lot. So square that, and then that becomes so a4 equals 4a squared minus 4a plus I. Okay, and we know what the value of a squared is, so we substitute that lot into that lot. Okay, so that becomes so that's a4 equals 4 times 2a minus I, so minus 4a plus I. and then that becomes so that's 8a minus 4i minus 4a plus I, which then becomes 4a minus 3i. Okay, yeah, yep, so it's just cross-checking. Yeah, that's fine. And then so we know the value of the matrix. Right, so that's minus 3, 16, 1, minus 1, sorry, 5, right, and that becomes 3, 0, 0, 3. Okay, and then simplifying further, we get so 4 minus 3, 4 times minus 3, that's so minus 12. 4 times 16, that's 64. Then minus 4, that's 20 there. Minus 3, 0, 0, 3. Simplifying further, so subtracting that lot from that lot. So that becomes minus 15. So minus 15, 64, and minus 4 and 17, which is our a to the power 4. So yeah, I'm just going to check that with MATLAB. Right, so a equals so minus 3, 16, and minus 1 and 5. Right, so then a to the power 4. So minus 15, 64, and minus 4 and 17. So here we are. So yeah, so that's all, that's the answer anyway. So it's all correct. So yeah, so hopefully that's helpful. And if there's any questions that you want to ask, just feel free to use the spaces at the bottom. And yeah, so have a lovely end to the week. And I'll see you soon. Okay, take care and cheers. Bye-bye.